Hi, my name is Monique Warren and I'm an environmental engineer. I work at Lawrence Livermore National Laboratory. An engineer in general is somebody who helps solve real-world problems. So an environmental engineer helps solve problems that are in our environment. So that might be in air or water or soil. And I work with water. There are things in your home that you might not even realize an environmental engineer helped you with. So the water that you get when you turn on your tap to get like a glass of water, that water has to come from somewhere. So an environmental engineer helps to figure out where that water is coming from, and they help figure out how to make sure that water is clean when it gets to you. They will help design treatment processes, so there'll be like whole treatment facilities where that water has to go through all these different kinds of treatments so that when it comes to your home, it's nice and clean. And when you flush your toilet or when you take a shower, that water has to go somewhere. So we call that water wastewater, and all that wastewater from everyone in the world has to be treated before it can be sent to somewhere like the ocean. And it has to be clean when we send it to the ocean. So environmental engineers help with that. Today I'm going to show you a little bit more about what I do by doing a really fun experiment called edible aquifers. And this experiment's super fun because it uses ice cream. So to do edible aquifers, we're going to need to go to the kitchen. If you didn't know, an aquifer is an underground storage of water. So if you take nothing else from this experiment, I want you to know what an aquifer is. Our first step for edible aquifers is to take our gummy bears and place them inside our cup. And today our gummy bears are going to represent gravel. Now gravel is great because it has a high permeability. So permeability is basically a measure of how much space a material has for water or another liquid to travel through it. So something with a high permeability, like gravel, has a lot of space for water to travel through. Something with a low permeability, like clay, doesn't have a lot of space. So we have our gravel, represented by gummy bears. And now we're going to take our clear soda and just pour a little bit on top of our gummy bears, just enough to cover them. And that's going to represent groundwater. Groundwater is just like the name says, it's water in the ground. And we're going to take our ice cream, our vanilla ice cream, and just lay it on top. And we want to keep nice clear layers, so we don't want to swirl it around too much. We just want to lay it nice and gently on top. And now I have my groundwater and my gravel, and I have my layer of ice cream. And our ice cream is going to represent a confining layer. A confining layer can be made of something like clay with a low permeability, and it's just going to be like the lid or the cap for the aquifer. And on top of our confining layer, we're going to put our Oreo pieces. They're going to represent soil. And I have green sprinkles that I'm going to use to represent grass. And maybe you have colored sprinkles and they can represent flowers. To get access to water stored in an aquifer, what you need to do is drill a well. So today we're going to drill a well using our straw. So we're just going to take our straw and twist it gently through the layers and try not to mix it around so we can keep our nice clean layers. And I'm going to hit the bottom of the cup, and now I have access to the groundwater stored in my aquifer. And we install pumps in our wells to pull the water out of the well. So today your mouth is going to represent your pump. So what I want you to do is watch my aquifer. So tell me what changes when I pull water out of my aquifer. So the water level started around here, and now I've drawn it down to here. This is really important to know about aquifers, is that they're a storage of water. They're not a limitless supply of water, right? They're not like the ocean where it's just tons and tons of water. So once you take water out of the aquifer, that water is gone. And what you need to happen is it has to rain. So I could use my groundwater to make it rain on top of my aquifer. And that water will infiltrate the soil, it'll infiltrate the grass, and go down and refill that aquifer. So if you take water out too quickly, what can happen is you can make your aquifer dry. And that's really bad because then that aquifer isn't really good to us anymore. So what we want to do is we want to pump some water out and then allow it to rain so that water can go back into the aquifer and recharge it, which means to like refill it. And once that water level comes back up, we can pump water out of that aquifer again. So now I'm gonna show you what happened at the place where I work. Before the lab was there, it was actually a naval air base, and they had a lot of airplanes and airplane engines that needed to be cleaned, and they used these really strong chemicals to clean those engines. And some of those chemicals were spilled on the ground. So if I take this strong chemical of green dye and spill it on top of my aquifer, let's see what happens. So I spilled some chemical on the top, and I'm just gonna make it rain to make this a little faster. And you'll see that green chemical that I spilled on top of my aquifer is now coming down and contaminating the water stored in my aquifer. So this is really important because what you do and what you spill on the surface can infiltrate and can contaminate the subsurface, what's below the ground. So the groundwater at the lab became contaminated. So that's why I work there, because our job is to clean up that contamination. So we pump the water up out of the aquifers, and we send it to different treatment facilities where we can pull out that contamination, and then we'll have clean water that we can send to like a lake or a river. As we pump the contaminated water out of the subsurface, we draw that contamination in. I'm doing octopus arms, and we treat that water underground, and that's really, really important. What can also happen is you can spill a different chemical on the surface, like this dangerous red chemical. You can spill it on the surface. I'm gonna make it rain again. And now it's mixing with that green chemical and coming down to contaminate my aquifer. So that's a big problem too, because now I don't just have one chemical I have to treat, I have two chemicals I have to treat. And so that makes our job a little more complicated because we have to figure out how to pull out different chemicals, different contaminants from the water. So our treatment facility might have one treatment process to pull out the green chemical, and it might need a different process to pull out that red chemical. So you might have like a water filter at home that you use to filter your drinking water. Like I have my water filter here, and inside your water filter, this column right here, there's what's called activated carbon. So activated carbon is what pulls the contaminants, the bad stuff, out of the water. And we might use something similar, but a much bigger, filter to pull out all the green chemical, and that might be one treatment. And we might need a completely different treatment for the red chemical. And that's the end of our experiment. So while you enjoy your ice cream treat, I just want to tell you a little bit more about how I got to do what I do. When I was a kid, I really wanted to be a great chef. There was this TV show I like to watch called The Great Chefs of the World, and I loved seeing all the different things they were able to make. I remember there was this big cream puff tower that had just this spiral of spun sugar around it, and I was so fascinated by all these different dishes. They all looked so intricate and beautiful, and I couldn't wait for the day I could make something like that. I remember just playing around in the kitchen or writing, a made-up recipe and being excited about the idea of being a chef. And my dad saw that, and he was like, hey, have you ever considered chemistry? Chemistry is kind of like cooking, where you take different things and you put them together and you get something new. It's kind of like cooking, like you have different ingredients and you mix them up and maybe you create something new. And I hadn't thought about that. I hadn't thought about how similar science was to something that I liked. And so as I grew up, I always had that in the back of my mind, that like, oh no, science is pretty cool. It's really similar to the things I like. And I got to meet different scientists growing up, and I got to go to really cool events like Expanding Your Horizons. And I got to do this really cool program at the University of Southern California in high school called Discover Engineering. And at that program, we did really hands-on experiments for 4 weeks. We made a vending machine, we made a rescue robot, we built a bridge out of balsa wood. We did all these really cool things, and they kept telling me how engineers get to solve problems. And I love that. I love that engineers were like superheroes. They would see things that were wrong in the world and then figure out a solution for them. And I was like, I want to be a superhero. I want to be an engineer. And I kind of took that and ran with it in high school and decided, no, I'm gonna be an engineer. I'm gonna solve problems for people. And I in college figured out that I really love water, and I love getting to solve problems that are related to water. And so that's how I decided to become an environmental engineer. Thanks so much for watching and for doing this experiment with me. Stay safe out there. Have a great day. At the lab where Rocco